Alright, this video is for the first half of Unit 12, Day 9 review. These are all questions that were pulled from Regents exams that have been out since Common Core, and this is all of the ones that have ever been put on there. Alright, the first one says the hours of daylight in Utica Y and Utica in days X from January 1st, 2013 can be modeled by that trig equation. How many hours of daylight to the nearest tenth does this model predict for February 14th? How many hours of daylight? So that sounds like a period. So the hours of daylight in X days. From there. Okay, so no, what we got to figure out is how many days we've had since January 30th. Well, there's 31 days in January, and then 14 more, so that means we would be plugging in, alright, number of days since January 1st. Alright, so let's call that a 44. So we're going to plug in a 44. Make sure our calculator is in radian mode, and we're going to type that in. 3.06 sine parentheses 0.017 times 44 minus 1.4 end parentheses plus 12.23, and I'm coming out with 10.37. So to the nearest tenth, that would be choice number 2. Consider that trig function and the function represented by Q. Determine which function will have a smaller minimum value for the domain -2 to 2. Well, the smallest value of Q is -8, so make sure your calculator's in radians and go get yourself a table. Y equals 2 sine 3x end parentheses plus 1. Get table of values, and we're looking for -2 to 2. We have 1.55, 0.717, 1.2, 0.44, 1.8. Oops, that's not even on there. So which one has a smaller minimum value? -8 definitely wins. Justify your answer. Well, we'll say Q of X has the smaller one. Justify the answer just means copy down the other table and show them why. The resting blood pressure of an adult patient can be modeled by this function on a set of axes. Graph over the domain 0 to 2. Alright, so we need amplitude, frequency, period, and critical points. So the amplitude is the number in front, 24. Frequency is the number touching the variable, 3 pi. Period is 2 pi divided by the frequency, so 2 pi divided by 3 pi is 2/3. And critical points, when you divide it by 4. So 2/3 divided by 4, keep it, change it, flip it. 2/12, so 1/6. Okay. And it has a vertical shift midline of 120. Okay, well, let's see. I can figure out how to count the graph. Well, look at here. Our critical points were 1/6, and look, they made us 6 lines to get between 0 and 1. How convenient. So I can count by 6. 7, 6, 8, 6, 9, 6, 10, 6, 11, 6, and 12, 6 makes 2 Perfect. All right, now my highest point is going to be 144. And if I take my midline minus my amplitude, my lowest point is going to be 96. Let's see. I don't know. Can we count by sixes maybe? 96, 102, 108, 114, 120, 126, 132, 138, 144. Perfect. Okay. The only reason I thought about sixes is because I had to hit the 96, and it worked. Alright, here we go. Our midline is 120, so I'm just going to sketch that in there. That's my ground zero. We are graphing a cosine curve. That means the graph starts in the air at my maximum. We said my maximum was 144. So 144, midline, lowest, 96, midline, highest, midline, lowest, midline, highest, midline, lowest, midline, highest. Remember, these are supposed to kind of look like cursive V's, not like straight printed V's. Best you can. There is your graph. Alright, so here they give you a graph and they want the values of A, B, and C, which is your amplitude, your frequency, and your vertical shift. Alright, well, let's see. The highest is 5, the lowest is 1. 5 plus 1 divided by 2 is 3. So that means our vertical shift is 3. So those choices are out. Now we just got to figure out what the amplitude is. So how high above the midline? It looks like it went up 2. So my amplitude has to be 2. And therefore I don't even have to find the frequency, because the only choice can be number 1. The average monthly high temperature in Buffalo can be modeled by that equation. State to the nearest tenth the average monthly rate of temperature change between August and November. Explain the meaning in context of the problem. Alright, so August is month 8. November is 11, so we're just going to plug them both in. So we're going to find B of 8. And we're going to find B of 11. Alright, make sure you're in radian mode. And let's see, we have 25.29 sine 0.4895 times 8 minus 1.9752 in parentheses plus 55.2877, and I'm getting 78.8662248, and second enter so I don't have to type the whole thing over again. And I'm going to go put times 11. And hit enter. And I get 48.59796025. And it said, state to the nearest tenth the average monthly rate of temperature change. Alright, so I got to subtract those. Minus. It said to the nearest tenth, so when I subtract them to the nearest tenth, I get 30.3. Explain the meaning in the given context. The average temp drops 30.3 degrees between August and November. That works. As theta increases from negative pi halves to 0 radians, what will the value of cosine do? Here's 0 radians, negative pi halves. Remember, we go clockwise for negative degrees. So they want to know what happens to the cosine value. Well, in negative pi halves, the cosine value is 0. And at 0 radians, the cosine is 1. So if you're going from negative pi halves to 0 degrees, your cosine is going to travel from 0 to 1, which is choice number 4. The depth of water at a marker 20 feet from the shore of the bay is depicted on the graph. Find the equation. Alright, well, 2 of the equations have an amplitude of 5, and 2 of them have an amplitude of 9, and reverse for midline. So let's go find those first. The highest is 14, they're counting by 2's, and the lowest is 4. So 14 plus 4 divided by 2, 18 divided by 2 means 9 is the midline. So if 9 is the midline, it's the vertical shift, and that means choice 2 and 3 are out. Both 1 and 4 have an amplitude of 5, so we're going to go with that one. Sure enough, from 9 to 14 is 5. Now, one of them says cosine, and one of them says sine. And since the graph goes up first and then down to the trough, that is a sine graph, which means number 4 has got to be our choice. Notice all the frequencies were the same, so I didn't have to do anything with the period because all the frequencies were the same anyway. Alright, the height of a piston is given by that equation. Determine the average rate of change of the piston's height on the interval of 1 to 2. Excuse me, at what value of t to the nearest tenth of a second does h of t equal 0 in the interval from 1 to 5? Okay, so first off, they want the average rate of change from 1 to 2. So we just have to fill in a 1 and fill in a 2. Actually, I'm just going to go put that on a table. So we'll go type it in the table. We have 12 cosine pi thirds x plus 8. And in the table, 1 is 14 and 2 is 2. So what's the average rate of change? That's y minus y over x minus x, and that would be negative 12 over 1. So the average rate of change in centimeters per second is negative 12 over 1. At what value or values of t to the nearest tenth of a second does h of t equal 0? Whew. Alright, well, honestly, I'm not too sure about this one. So we have on the calculator that 3 is a negative 4. Now if I hit graph, I can see where this graph crosses 0. And so I'm going to use my graphing calculator trick, where I'm going to go second trace number 2 for zeros, and it's asking for a left bound, so I gotta move my flashy close to it, hit enter, move flashy past it, hit enter, and the 0 comes out to be 2.2 to the nearest tenth. And then there's another one, so I'm going to go back second trace, number 2 for 0, move flashy to the right until just before I hit my root, hit enter, just past my root, hit enter, and Flashy says it also has a root at 3.8 to the nearest tenth, and the next root is way past 5, so it's 2.2 and 3.8, and quite honestly, using your calculator that way is the most efficient way I can think of to do that problem. The temperature in Times Square during a day in August can be predicted by that function. X is the number of hours after midnight. According to this model, the predicted temperature to the nearest degree at 7 p.m. is... Alright, so from midnight until 12 p.m. you have 12 hours. Sorry for the dogs. And then 7 hours afternoon means 19 hours later. So we're going to fill in a 19. Alright, so you just got to type that into your calculator. 8 sine 0.3 times 19 minus 3 in parentheses plus 74. And I'm getting 77.4 degrees, so to the nearest degree, answer is number 3. Griffin is riding his bike down the street in Churchville, New York, constant speed, when a nail gets caught in one of his tires. The height of the nail can be represented by that function, where t represents the time since the nail first became caught in a tire. Determine the period f of t, interpret what the period means in the context, and then graph at least one cycle of f of t. Does the height of the nail ever reach 30 inches? This was a 6-point question on a Regents exam. Alright, so the first question, determine the period of t. Period equals 2 pi divided by the frequency, which is 0.8 pi. The pi's cancel out. 2 divided by 0.8 is going to end up giving us 2 divided by 0.8 is 2.5. Alright, so that's 2.5 seconds. So determine the period. Period is 2.5 seconds. Interpret what the period means. It means it takes 2.5 seconds for the nail to go all the way around the tire. On the grid below, graph at least one cycle of f of t that includes the y-intercept. Alright, so the amplitude is 13. The period is 2.5 seconds. Alright, so make your axes. There's x, there's y. Our midline is 13. So, actually, you know what I'm going to do? That nail is never going to go underground, so I'm going to make my axes all the way down here. That way I can count by ones, because I have to get as high as 26. I'm not counting by ones either. 1, 2, 3. Let's count by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Okay, I knew that because my midline is 13, my amplitude's 13, so my highest point is going to be at 26. So I had to make sure I could put that on the graph. Midline is 13, so I'm going to draw my midline right here. Okay. I know I have to graph 4 points. So 1, 2, 3, 4 points will make a full cycle, and that last one is going to be labeled 2.5 because that's my period. Alright, so it's a cosine curve, and because it's negative, it's upside down, so we're going to start down 13 from the midline, which is down to the 0. So then we're going to go to the midline, up to the maximum, down to the midline, back down to the 0, which is the ground. Connect the dots. And there's your graph. That was a 6-pointer on the Regents exam. Oh, determine the height of the nail, or determine if the height will ever reach 30 inches. No, the max height is 26. Which function's graph has a period of 8 and reaches a maximum height of 1 if at least one full period is graphed? Alright, so if you want a maximum height of at least 1, so you take your midline and add your amplitude. So negative 3 plus 4, well, the maximum is 1. 5 plus 4, the maximum is 9. Negative 3 plus 4 is 1, and 5 plus 4 is 9. So, gee, they all have a maximum height of at least 1. So we have to work on the period. So the period is 2 pi divided by the frequency. So I want the period to be 8. Cross multiply. So my frequency has to be pi fourths. So, oh, it wants a maximum height of 1. Sorry, I thought that was at least 4. So maximum height of 1 would be either choice 1 or 3. And the period or the frequency we just found out had to be pi fourths. So the answer is choice number 1. The height above ground for a person riding a Ferris wheel is given by that equation. How many seconds does it take to go from the bottom to the top? Now, from the bottom to the top is only half a cycle. So we want to find the period and divide it by 2. So period is 2 pi divided by the frequency. Frequency is pi over 45. Keep it, change it, flip it. The pi's cancel. And the full period is 90, which is a choice. But from the bottom to the top is only half a period, half a cycle. So it ends up being 45. Alright, we need to graph this over the domain 0 to 2 pi on the set of axes below. Okay, amplitude is 3. Frequency is 2. Period is 2 pi divided by the frequency, so we get pi. And critical points are going to be pi divided by 4. So 1 pi fourths. Actually, you don't even need to do that. Okay, so the period is pi. They want us to graph all the way to 2 pi. So there's going to be 1, 2, 3, 4 points to get to pi. 4 more points will get you to 2 pi. If you wanted to, you could count by pi fourths and label them all, but you don't have to. This will work. Alright, midline's at 2, because that's the shift. So I'm going to graph my midline. Since my amplitude is 3, I'm going to go up to 5 and down to negative 1. Alright, sine graph. So sine starts on the midline, goes up to the hill, down to mid, minimum, midline, max, midline, minimum, midline. Alright, this will be the last one for this video. The average monthly temperature of a city can be modeled by a cosine graph. Melissa has been living in Phoenix, where the average annual temp is 75. She wants to move and live where the annual temp is 62. When examining the graphs of the average monthly temperatures for various locations, what should she focus on? Alright, so the average is kind of like the middle. And if we talk about trig graphs, the middle of a trig graph would be the midline, which is halfway between highest and lowest. So on this one, if she's examining average temperature, she wants the middle temperature, she wants to look at the midline. Alright, battery on my iPad's about to die, so I am going to stop here, and I will put the rest of the problems on the next video.